This problem says, in the drawing, the weight of the block on the table is 422 newtons and that of the hanging block is 185 newtons. Ignoring all frictional effects and assuming the pulley to be massless, find A, the acceleration of the two blocks, and B, the tension in the cord. So, weight of this block here, I call it weight 1, equals 422 newtons. Of course, it's a negative 422 newtons. And weight 2 over here equals negative 185 newtons. Now in the book you see that the drawing shows that this block here is on the right hand side, and apparently I flipped the picture, and I'll explain that later when I'm actually done with this, why I did it. Anyway, let's look at what else we're supposed to look for. Well, one of the things is we have to find what the tension is. So the tension here on the block points in this direction, and I may want to call this T1. And especially since the tension here needs a direction, look at this tension here that is pointing upwards. There we go. That's why I'm going to put vector arrows on these here, because this one is vertically upward, this one here is horizontally to the left. So we're supposed to figure out what the tension is, so I'm going to make here a question mark for block 1, I'm going to make a question mark for block 2. We know what the weight is for block 1, so I could make a check mark there, but notice that the block, the weight here is being pulled down, that for this block here the normal force must equal the weight here, so I put a check mark here for the weight and a check mark for the normal force. But the two are equal, so actually these two check marks here for the normal force and the weight, they cancel out, they divide out, they don't give us any more information. That's not true for this weight here. That one here is important because that's actually the weight that pulls everything down. So here I definitely will make a check mark here that I need. I'm also going to do some black because we do need that. As I said, the other two here, the two orange ones, well, we know them, but they're not going to give us any new information. We know the masses for both. Just divide by negative 9.8, and of course divide by 9.8 to get the mass, and you divide by that negative to get rid of the negative from the weight, because you can't have a negative mass. So 43.1 kilograms on this one, and the other one has a mass of 18.9 kilograms. Okay, now we're also supposed to figure out the acceleration, and we do note that the acceleration for both of these here is going to be the same because the two are connected. So whatever this one is accelerated down, this one is going to be accelerated to the left. Before I actually start out with this problem, let me talk about the forces that are involved here. I did talk about the weight and the normal force over here and the weight over here that is actually pulling the whole thing down. But let's look at the tension here. There's a tension in this direction and there's a tension in this direction for this block up. And these two you have to obey Newton's third law. Now Newton's third law here and over there say that they have to be equal and opposite. Well, so to say they're definitely equal, this one here are the opposite. Well, this one here is a negative and this one here is a positive, which is also the reason why I turned that around. I'll get back to that at the very end, and I'll revisit that. So this one here is up, so it's positive. This one here is negative, so that's okay. So we have equal and opposite. Still though, this one points left, this one is up. That is definitely not in the opposite direction. So what's happening here? Well, it's the pulley itself that redirects the tension, the force here. And I'm going to attempt this one here. What is actually the rope do to the pulley? Well, it's going to exert a force on that pulley. In fact, it's going to push it about this way. So that's kind of the reaction force for both of these. And if I take that into components, then here I actually have that equal and opposite force for this tension, and here I have that equal and opposite force for that tension. Now, I would also have to have an equal and opposite force for this one here, and using yet one more color, kind of running out of colors here, I guess. Green is actually the table pushing up on it, on the pulley. Whoops. So here it's the tension on the cord pulling on the pulley, and then here the pulley pulling on the cord, and here the same thing, the pulley pulling on the cord, and here the cord pulling on the pulley, and then for the pulley overall it gets a tension in this direction, and so the pulley is pushing on the table and the table is pushing back on the pulley, making this part stable and making this part here also stable as far as the cord and the pulley are concerned, but of course because of the weight the whole thing is dynamic, so it's going to fall. Okay, so far so good on this one here, so far so good on Newton's third law. And now let's do a calculation, and there are also two things to do. One of them I call the quick way. Quick way, where consider both blocks as one system, and evaluate Newton's second law in that fashion. So sum of the forces equals mass times acceleration. And now the sum of the forces, the only force that really accelerates it is the weight. So I'm going to write the weight of block 2, so I'm going to write that down, weight of block 2. And then what the other two forces are doing, T1 and T2, well, they're going to be equal to each other, so they actually divide each other out, or cancel each other out, because T2 is positive, T1 is negative, remember, up and left, and both have the same value due to Newton's third law. And on the right hand side I have, well, what mass is accelerated? Well, both masses are accelerated because they're connected. So it's going to be m1 plus m2 times acceleration. Okay, now to determine the acceleration, I of course have the weight 2, block 2, divide by the two masses, equals, and then you're going to come up with something. And notice that the weight 2, of course, is negative, and this is positive here, and it gives us a negative acceleration. And that makes sense because the block is falling down, and the other block is moving to the left. That gives us a negative acceleration. That was the quick way. The